For this video, we're going to be exploring how to multiply and divide radicals. So, we have a problem that looks like this. The square root of 3 times the square root of 2. We want to know, what does this equal? Well, one of the rules when it comes to radicals is that when we multiply them, we can multiply the coefficients on the outside and we can multiply the numbers that are underneath the radical. Well, in this case, we don't have any coefficients on the outside. They both have a coefficient of 1, so we don't have to worry about that. But inside the radical, the square root of 3 times the square root of 2, that's the exact same thing as saying the square root of 3 times 2. Well, 3 times 2 is 6. We get the square root of 6. Now we want to take a look. We want to make sure, is this 6 as simplified as we can get? Are there any perfect squares that go into 6? Well, the factors of 6 are 6 and 1, 3, and 2. Taking a look at those, none of them are perfect squares, so therefore, this is as simple as it gets. Our answer is the square root of 6. Alright, so now we want to take a look at a slightly more complicated problem, but one that's pretty similar. So in this case, we're going to take a look at 5 times the square root of 14 times 4 times the square root of 6. Alright, so looking at a problem like this, I do have coefficients. I have 5 and 4. And I have numbers under the radical, 14 and 6. So, how do I do this? Well, I'm going to multiply together my two coefficients. So I'm going to multiply 5 times 4. That gives me 20. Then I'm going to also, underneath my radical, I'm going to multiply 14 times 6. So I do 14 times 6. So if I multiply those out, I get 20 times 84. 14 times 6 being 84. All right. Now it looks like I'm done, but I need to think about this for a second. 84 is a pretty big number, and it has quite a few factors. So let's think, are there any factors of 84 that are perfect squares? Well, we know it's divisible by 2. 2 isn't a perfect square. But if I divide by 4, I end up getting 20 times the square root of 4 times 21. All right? And we know 4 is a perfect square. 21 breaks down into 7 and 3, and 21 and 1. None of those are perfect squares. So to simplify this further, we have to take this square root of 4. Square root of 4 is 2, so I get 20 times 2 times the square root of 21. 20 times 2 gives me 40. And so I get 40 times the square root of 21. That is the answer to this problem. 21 is as simplified as this radical gets, and we have 20 times 2 is 40. So this is my final answer for simplifying this problem up here. All right? Now the same process works just as well for higher level roots as it works for square roots. So for example, up here I have 2 times the cube root of 18 times 6 times the cube root of 15. So we're going to do the exact same process. We're going to multiply 2 times 6, gets us 12. We're going to multiply inside the radical 18 times 15. All right, so if we take a minute, we go do this multiplying, 18 times 15, we end up getting, put the cube roots in here, the cube root of 270. So now what we need to think is, are there any perfect cubes that go into 270? Well, looking at it, it should be pretty obvious that 270 factors into 27 and 10. 27, we know, is a perfect cube. So this is 12 times the cubed root of 27 times 10. Well, we know the cube root of 27 is 3, so that comes outside of our radical. 12 times 3 times the cubed root of 10. 12 times 3 is 36. If we look inside here, 10 does not have any perfect cubed factors, so that is as simple as it gets, and our answer is 36 times the cubed root of 10. Exactly the same as we did with the square root problems. So the process is always the same. Multiply your coefficients, multiply your numbers underneath the radicals, then simplify. So if we take a look at this problem right here, well, we could do this a number of ways. We could multiply 20 times 75 first, get our answer underneath the radical, and then simplify. Or we could do the way that I think we should do that, and that is simplify these first and then multiply them. So let's take a look at this. 20. Do I know of any perfect square factors of 20? Well, it should be immediately obvious that 20 is 4 times 5, and 4 is a perfect square. So this becomes 2 times the square root of 5. Looking at 75, can I think of any perfect squares that go into 75? Well, I end up getting 75 is 25 times 3. 25 is a perfect square. Square root of 25 is 5. So I get 5 times the square root of 3. 5 can't be simplified, or square root of 5 can't be simplified anymore. Square root of 3 can't be simplified anymore. So I do my multiplying. 2 times 5 gets me 10. Square root of 5 times the square root of 3 is the square root of 15. There are no perfect square factors of 15, so that's my answer. All right, the exact same process. Simplify, multiply, simplify. All right, so now we're going to go on to dividing. If we're dividing, we do the exact same process once again. So, look at the square root of 28 divided by the square root of 2. Just like multiplying, we could rewrite that as the square root of 28 divided by 2. The numbers that we're dividing, we can move right inside the radical. 28 divided by 2 is 14. So I get square root of 14. I look and I think, well, what are the factors of 14? 7, 2, 1, 14. None of those are perfect squares, so that is my answer. All right, so we do it the exact same way as multiplying. Anything that's inside the radicals, we divide, and then we simplify our answer. Moving on, we've got a problem that looks like this. Now we've added some coefficients in. 6 times the square root of 15 divided by 3 times the square root of 5. Well, if we remember back to when we were dividing exponents, we should know that we could cut this in half. So that I get 6 divided by 3 over here times the square root of 15 divided by the square root of 5 over here. Well, 6 divided by 3 gets us 2. Square root of 15 divided by square root of 5. 15 divided by 5 is 3. Square root of 3. No simplifying to be done in here. 3 is a prime number. So that's our answer. 2 times the square root of 3. All right. And finally, our last example. We've got 15 times the cube root of 54 divided by 20 times the cube root of 2. Well, do this problem. Once again, we split it up into two division problems. 15 divided by 20. The cubed root of 54 divided by the cubed root of 2. Over here, 15 divided by 20. That reduces to give us 3 over 4. Over here, square root of, or cube root of 54 divided by the cube root of 2. Well, 54 divided by 2 gives me the cube root of 27. Well, we know that the cube root of 27 is simply 3. So we've got 3/4 times 3, which gives me 9/4. No radicals even in my answer, and we're done. So now you know how to multiply and divide radicals.